So I want to make sure everybody's on the same page and understands what is OpenStack. So the project describes itself as open source software for creating private and public clouds. So what does that mean? I like to see it as you have an operating system for your servers, and OpenStack is like an operating system for your data centers. All of it is modular. By design, it allows it to scale. It allows you to manage large pools of compute, storage, and networking throughout your data center. And it's all through a common API that gives administrators full control of the hardware while empowering their users to provision the resources that they need for their applications. So where did it all begin? And why and who? So back in July 2010, Rackspace, you may have heard of them, wanted to create an open source cloud computing platform, initially looking at object storage. To help break from the shackles of proprietary clouds and software to give users choice and flexibility. At the same time, NASA was empowered by the US government to assist in the Open Government Initiative, which set out to improve collaboration between government bodies and the public. This is a high-level timeline of OpenStack history, early history. This is great. This is an interactive website. When these decks get shared, you'll get access to this. It's a horrible URL. But it's a great website. You can scroll through and see the whole history. But essentially, our very own Jim Curry, back in the day, contacted some quite infamous faces you may recognize at NASA. And I'm pretty sure Beer was involved along with Curry to help launch OpenStack in July 2010. I was expecting laughs then. I don't know, it's 4:30. I don't know you need more Red Bull, but go with it. When I start laughing, you have to laugh as well. That's the rule. So here we see NASA as well open source their own compute platform, Nebula. So they ran out of steam with their initial platform. They started off with Eucalyptus. And through a couple of bad decisions about the way the Eucalyptus project ran their open source efforts, basically NASA needed to break away and actually create their own platform. So they had Nebula. So the two minds came together, and that's when OpenStack was born. But as the months went by, it wasn't in anyone's best interest for Rackspace to have the perception of overall control of OpenStack. Despite, at launch, another 25 companies were involved in the project. So, in September 2012, the OpenStack Foundation was born. And Rackspace transferred all the IP and governance of OpenStack into the non-profit, member-run OpenStack Foundation, which since then manages the software and the community. The community is huge. With nearly 25,000 registered users, and they're the ones that actually take the time to actually do this, across 164 countries. That's pretty big number. And they're eligible to participate in the way the project is actually run. So they vote in elections, who gets to become representation on the board, who gets to be a project technical lead. They all have an input into how this software is run and the direction it goes into. And it really is one of the fastest growing open source communities in the world. So the OpenStack community collaborates around a 6-month time-based release cycle with frequent development milestones in between. And every 6 months, the community gathers for the OpenStack Summit to celebrate the latest release and start work on the next one. It's a week-long event which features keynotes, breakout sessions, and it's a very jam-packed event for people like yourselves to come together to talk to vendors, talk to different users, and actually put your input into where OpenStack is heading. So we just had the Vancouver Summit to celebrate the 11th release, which was Kilo. and start work on the next release, which was Liberty, which is due out in October this year. So did anybody get to go to the Vancouver Summit? So I did, and I know somebody else did in the room. The next one, if you're interested, and please keep up, the next one will be in Tokyo, which will celebrate the M release, followed by going over to Austin, Texas, where it all began, in spring next year. And then it'll come back to Europe at the end of next year in Barcelona. And I tell you one thing, I'm looking forward to that one where I get no jet lag. There you go, you're catching on with the laughs. There you go. Oops, maybe this will help. You can just read Dilbert. So what problems does OpenStack solve for? Well, massive IT data center sprawl gave birth to virtualization. But with more and more demands in the data center and from users and operators, virtualization only got you so far. And managing many racks and many data centers became very, very inefficient. So this is where OpenStack adds value. It's a means of adding an orchestration layer on top of the many, many different pieces of hardware in your data center. This provides efficiency and the ability to distribute workloads based on the demands of your users in your DC. So let's have a look at the OpenStack services. So pay attention, because if you don't ask me questions at the end, I'm going to be asking you questions. So we start off with a blank slate. That's no good. Try this one. So we start off with some hardware. And I hate to break it to you for people who are new to the cloud, but cloud actually runs on some physical tin. So we have some standard hardware, and on top of that, we put an operating system. So far, so good. And then on top of this, we have the OpenStack shared services. So one of them is Keystone, and one of them is Glance, and I'll tell you what they are now. So Keystone is the identity service. This handles all the authentication and all the authorization that happens within OpenStack. So all the services, all the users, all flow through Keystone to give access to the various features and functionality in the environment. So users that get created get told they were only allowed to use certain parts of the cloud or certain features. That happens through Keystone. Glance is the image management platform. So this is where you have your operating system images. So your Windows images or your Ubuntu images, they all live within Glance and allows you to put controls around that as to how they get accessed within the OpenStack environment for your users. That's where the good stuff happens. So you can't really have a virtualization platform without something that controls the hypervisor. So this is what Nova does. So let's make sure that you're on the same page. And I know a lot of people in the room are here because they like OpenStack and they're going to deploy it. So you already know that OpenStack is not a hypervisor. That was a missed message that people seem to have coming new into OpenStack. Nova is the thing which controls the hypervisor. So this is the thing which says, OK, give me an instance which is 2 CPUs, 4 gig of RAM, and 40 gig disk. That's what Nova does. Neutron, the thing that makes grown NetSec engineers cry. This is the software-defined networking piece. So Neutron allows us to have these great environments where you can have your multi-tier web applications. So this allows you to have your web application, your front-end web application layer. And then on a separate network, you can have your middleware layer. And then underneath, you can have your database layer. And you can put controls around each of these networks and how they work in your environment. And then we can use these networks to break out of the cloud and actually into traditional IT. So you can talk to your SQL servers, or you can break out to the public cloud. And last but not no means least is storage. And storage is split up into two currently within OpenStack. So the first we'll talk about is Cinder. Cinder is the block storage piece. So Cinder allows people to add in extra drives to their instances. So this is the equivalent of somebody who wants a 40 gig drive to add to their instance. And it's like a USB stick. You can't share that drive amongst all the other instances. So it's like me putting a USB stick into this laptop. My friend can't use that USB stick. I have to disconnect it and plug it into that laptop if they want to do this. Now, the use cases around Cinder are where we start talking about how we work in a more cloudy kind of way. So, for example, if you've got a MariaDB database, there is a world where you could spin that into an instance, and all the data gets written into the ephemeral storage to do with that instance. But if you lost that instance, you lose the data that goes with it. With Cinder, you would spin up an instance, run your MariaDB, but store your data on Cinder. And so if that instance died, sure, there would be a loss of service, or depends how you would cater for this. But ultimately, you wouldn't lose the data. You would just spin up a new instance and reattach that volume to that instance. And Swift. Swift is Rackspace's baby. So this is what we brought to the table originally. So this is the object store. This is where you store large volumes of data, some archive data, some backup data. But this is an API-driven storage system. It's not your traditional NFS. You don't do this for running your database applications on. This gives highly resilient storage across a scale-out storage solution. So this gives you, so the way it works is you upload data, and by default, and most people do this, is it replicates 3 times. And that replicates 3 times into different zones. But zones are really important. So zones in your particular installation could be a drive, a hard drive in your machine. It could be an actual machine. It could be a whole rack of machines. But the key thing is that data is replicated across those zones. So you can actually lose a whole rack of machines and still have access to that data. So it's highly resilient. And you can span globes now with the replication. Oops, next. And of course, driving all this is an API. And I hear frequently when I talk to my customers that this is quickly becoming a standard API. Now, I use that term quite loosely because obviously there are many, many different standards out there. But this is a very, very common API that you can use to control your complete environment. So you can have either your applications controlling your OpenStack environment, or those applications could be a Chef platform or a Puppet or an Ansible. But they drive the way you manage that environment through this orchestration API layer. And it's very consistent. And equally, it could be the command line. But ultimately, it talks to this API. Most people start off, though, through a GUI. And the GUI in this case is a web dashboard, which is called Horizon. It gets you so far. Like any piece of tech, you get more value by learning the command line, by learning the API, and the dashboard is used there for convenience. We have other services. So these are ancillary services, extra services you can add into your cloud. So one of them is Ceilometer. So this is the telemetry service. So this is the service which basically gathers all the data from your cloud. So this gathers data where you can report on how much network bandwidth usage has tenant A been using. How many CPU cycles has user A been using in the last month. So this is really good for billing purposes. And it also has another function when we talk about the next service, which is Heat. So Heat is the orchestration layer. So this allows you to define complete environments from start to finish within a very simple YAML file. So you can describe that you have something like a 4-node web application, a 2-node Galera service with a couple of load balancers, and you can tie all them together through relationships, and you can run that Heat template, and at the end of it, you come out with your complete solution. The reason why it ties into Ceilometer quite closely is you can use Heat to do auto-scaling. So Ceilometer will have alerts that you can set to actually say, okay, should certain thresholds be set, and they get breached, you can get Heat to spin up extra instances as well. So we get into the world of auto-scaling. And Neutron. Neutron is very complex, but very, very powerful. So Neutron has the ability to add in extra services. So these are extra plugins that you can use. So those terms on there are load balance as a service, VPN as a service, and firewall as a service. So load balance as a service is probably the most familiar to you. So that allows you obviously to use a Neutron API to create your load balancers within your application environment. So the interesting thing about this, and this is where things get really interesting for Neutron, is you may start off using Neutron to create HA proxy load balancers, just using the Neutron API. But as you start to grow out and expand your services, you may replace that driver, not use HA proxy, but use F5 instead. But the key thing is, you are still using that same Neutron API, despite the fact that you've just changed something at the back end. And ultimately, to the end users, they don't see any difference. They just see the fact that they've just created that pool with those members in, and they've got that VIP. VPN as a service allows you to tie multiple OpenStack clouds together. So some of these services are a little bit new, so be careful when you go and play with these things. But VPN as a service basically creates open VPN tunnels between two OpenStack clouds. So you can join these clouds together. And again, you do this through Neutron APIs. And you can, instead of it being OpenVPN, you replace the technology behind the scenes to do something a little bit more robust, but still you're using that same consistent interface to achieve that same VPN. Firewall as a service, again, very out there, but this essentially puts control of the networks that you create in your environment pretty much back into the control of network engineers. So I know some network engineers have a few palpitations when the idea of developers actually creating these complete environments and creating networks. So to actually put some controls around this at the policy layer really helps solidify and helps bring on board the rest of the teams taking on board OpenStack. So this is a project timeline of where we were and where we are now. So essentially this basically runs through where all the services were introduced at the different milestones. And early on, you'll see that there's a number of key services that start off. So obviously in the very first release, we had compute and object storage. And as we go through, we start to add in extra services. We eventually get to a world where we add in the likes of Neutron. And then, yes, we just scale out. We actually develop out new features as we go along. But the key thing is, at the very beginning, it was a very quick release cycle. It was 3 months. 3 months between each release. It was very, very quick. And then eventually, after the Cactus and Diablo time, we actually went to I say we, it's the royal we. We would go to a 6-month timeline. Hence why we now have the releases coming out every 6 months. But OpenStack is ready for the enterprise now. But what was the turning point? So if I go back to this slide, for me, I think it was around Havana. So I know people were deploying OpenStack in the early days. I know people were doing OpenStack around the Diablo and Essex. I was there doing OpenStack releases, trying to get this pushed through companies around about the Bear and Cactus release, and they were scary times. But certainly from Havana and onwards, we start to get to a point where the project has matured. We get to see the formation of the user committee, which was formed in 2013, which starts to take into account more user-focused features to actually be fed back into the OpenStack project. So we start to see a lot less shiny features getting introduced, and things start to get boring. I think there's reports out there which basically say, the last summit report came out saying OpenStack is now boring. It's just because there isn't these extra services that try and make OpenStack stand out. Now it's gone back to a world where things are very, very stable. And I say that turning point was Havana. So what features make this ready today? Well, first is scale. We can scale many parts of the OpenStack stack. So we can scale the controller services to suit the demands of your business. We can scale the compute layer. We can scale the storage layer. We can provide isolation of your users into projects. And those projects have specific resources they can access. We can have it where users can only access certain parts of your hardware or special hardware for special use cases. There could be a world where a physics department needs access to some specialized hardware within your OpenStack environment, but your contractors working on some web front end have access to a very common platform with a CPU ratio of 16:1. But it's all highly available. It's all wrapped around highly available services. So we don't have these conversations anymore like we used to of how do you make OpenStack highly available. The controller services are highly available. And then we have conversations with our customers about how to make their applications highly available without depending on the underlying architecture. And we at Rackspace, we provide an industry-leading 99.99% API guarantee on our installations too. So OpenStack has obviously gained a lot of attention from a lot of IT vendors in the industry. And it's probably fair to say that there's many more IT vendors you know who are working with OpenStack than they're not working with OpenStack. The list is phenomenal. If you go to the openstack.org website, you'll see an impressive array of big and small names that you might find you have running in your data centers. So it's here to stay. And big businesses are investing big bucks into OpenStack. And in fact, only yesterday, Cisco bought Piston Cloud, and then we had IBM buying Blue Box. So we have all these big traditional IT companies that are buying into OpenStack. So it's definitely here to stay. So OpenStack works across the industry. I can't put my finger on any one industry where OpenStack works best. But I can guarantee that OpenStack works best for companies that want to work more efficient and more agile. So we have the likes of banks and financial institutions picking this up now. We have media, we have gaming companies, we have a whole load of people which are now big and small are looking at how they can take advantage of OpenStack. So let's have a look at a couple of use cases. So you may have heard of some of these names. So we have Walmart. So Walmart is a very, very large user of OpenStack. If you saw Tim's slide this morning at the when he's talking about CERN, so CERN will run 120,000 cores in one of the data centers. Walmart are not quite up there, but they run 100,000 cores. And it's completely running OpenStack. And this is the platform that completely ran the Cyber Monday traffic. So for anyone who's ever wondering whether or not OpenStack is ready to handle this kind of volume of traffic, then these figures speak for themselves. You may have heard of PayPal. So PayPal runs 100% of its infrastructure on OpenStack as well. So this is really good. I think this really stands out as to where OpenStack has actually gone from and where it actually is today. So we now have these people which you depend on and you trust implicitly when you press that button to make your purchase, and that all runs on OpenStack. So that makes a lot of the people that I talk to in the banking industry, in the financial industry, take note of how these things are achieved. And I work with a company, the other one on the slides there, called Telerik. So Telerik basically enables developers, this is what they say, enables developers to build compelling apps. And they do, they're really good people. But the key thing is they serve 90% of the Fortune 500. So that includes the likes of NASA and Microsoft and the Parliament here in the UK. And they use a range of technologies at OpenStack like some of you people do. But they chose OpenStack to become, for greater agility and for faster time to market. And like anything going very fast, I'm actually at the end of my presentation. And I realized that, I started before the woman allowed me to talk, so I do apologize for that one. So does anybody have any questions? And bearing in mind that if you don't ask questions, I'm going to ask you questions on what those little icons were before. The answer is yes and no. But so most installations of OpenStack run KVM. So in one respect, that's actually one of the most tried and tested hypervisors. So, and given the fact that where KVM was before OpenStack started, you can pretty much say that OpenStack has really helped KVM grow in adoption. And with that, it's basically gone from, there was a perception, before then that Zen was good for great I/O, all that kind of stuff. KVM is definitely on a par now with some of these things. So, but yes, I would certainly say that most people deploy OpenStack with KVM. Is that an advantage? I say it's an advantage of the fact that it's tried and tested. Do people run with VMware? Yes, they do. Do people run with Zen? Of course we do. We do in our public cloud. What I would answer for that is you start to get to a point where, I'm just trying to make this a little bit simple, but do you really have to care about the hypervisor at some point? I think we spend too much time thinking very much knee-deep into the stack. And I think the good thing about the likes of Rackspace is we can take care of that for you, and we just concentrate on what happens above that. But to be fair, there is on the OpenStack website, there is a matrix of what features are supported and what isn't. I would point you to that, just in case there's some feature in there that says, oh yeah, I do need live migration, or something works better with live migration, for example. Nova allows you to use many, many different types of things. So I don't want to use hypervisors. So obviously your traditional hypervisors, your KVMs, your Zens, all that kind of stuff. Yes, you can get it to control LXC, you can get it to control Docker. Again, they're listed in this matrix on the OpenStack website. And you can get it to control bare metal as well. So bare metal is a very interesting use case. So we use bare metal in our cloud. I don't know if any of you use the on-metal service in our public cloud, but that's basically Ironic, the bare metal service. So this allows people to, instead of making that decision of, do I really want to run my application within a virtual environment, they now get full access to the raw machine and take advantage of the features of a raw machine. But they do it in a very consistent way. They do it in the same way as you would control your normal virtual machines. So it allows you to operate your environment and I want to say not care too much about what it runs at the back end, but you're now making better decisions of where to run that application. Yeah, so essentially, OpenStack are a loose coupled services. They're just a whole load of web services. We bring them together and we call it OpenStack. So each of these services are basically all open source projects that fit under a common umbrella. And then what you're talking about is you're asking for basically a distribution. So the difference between what I'm talking about pure OpenStack, what you would do is you would take something like Rackspace Private Cloud and actually use services to wrap it all together to give you the platform that you need. So do you need the likes of BMC, or can I click next on this kind of stuff? No, it's not a single CD install kind of platform. The value in OpenStack is laying down OpenStack correctly for your environment to give you the resiliency it needs. So for example, Rackspace Private Cloud, if you were looking down this route, Rackspace Private Cloud basically gives you three controllers which are all wrapped together to give you a cluster of all those services. So where you've got Keystone and Glance and the API services and the back-end services which actually support this. So there are other features other software that needs to run, like a message queue like RabbitMQ that needs to run in there. We wrap them all around load balancers and things like Galera to actually give you your highly resilient OpenStack environment. But if you went and actually download the source code, you don't get that out of the box. So that's why you take a distribution or a partner to actually deploy this. So yeah, you still need all your traditional stuff of like, I need to PXE boot some operating system, I need to lay down this software on top of that. But we do that. We do that through our playbooks.